Okay, rationalizing expressions. When we're working with complex expressions that involve radicals, which is that root sign, we often want to rationalize, which means simplify or remove that radical, the root sign. And we do this by finding an equivalent fraction that doesn't have the radical in either the numerator or the denominator, and we do this in order to simplify that expression. In order to rationalize the radical, we're going to multiply by the conjugate radical, which is an expression of equal magnitude but opposite sign. So we're going to start by just stating what the conjugate radicals would be of these expressions. Okay, so they have to have equal magnitude. So they have to have the same values, but they're going to have opposite sign. So root x plus 1, its conjugate radical is root x minus 1. Root x minus 5 and 6 have a conjugate radical that is root x minus 5 minus 6. And root x plus 3 has a conjugate radical that is root x plus root x plus 3. Okay, so I'm just switching the sign. This is the equal magnitude but opposite sign, and we'll see why this happens in a minute. Okay, so first we're going to look at rationalizing the numerator in this expression. So the first thing we want to do is we want to identify what that conjugate radical is. So I've got x minus 2 minus 5. Now, because I am creating an equivalent fraction, whatever I multiply to the top, I also have to multiply to the bottom. Okay, I'm going to put some brackets on here just to make this a little bit clearer. And now I'm going to FOIL this expression. So I'm going to go first times first. And a root times a root is just, a square root times a square root is just whatever that is underneath the square by itself. So x minus 2. Root x minus 2 times by negative 5 is going to be negative 5 x minus 2. Positive 5 times root x minus 2 is going to be positive 5 root x minus 2. And finally, positive 5 times negative 5 is negative 25. On the bottom, I am actually going to leave this in factored form right now. And I do this because I might be able to cancel some terms. And so I don't want to get ahead of myself. So I'm just going to leave it in factored form. I might change it to expanded form later. Okay, now that I have done that, you should be able to see that these two center terms here are equal but opposite, and therefore would come to 0 if we combine them, which is great, because then left on the top, all we have is x, negative 2 and negative 25 is negative 27, and on the bottom, we have this expression, which I'm going to multiply through now just to see what it looks like, because the current denominator doesn't match anything in my new numerator, so I can't cancel anything. So I'm going to multiply it through to see if maybe I can cancel anything in that way. So I'm going to have x times x minus 2 and x times negative 5. And I still can't simplify anything, so then that's my final solution. Let's try another example. Okay, so I'm going to, in this case, rationalize the denominator. So my first step is going to be to write the conjugate of the denominator. It's 2x and 3, but my conjugate is a positive instead of a negative. Because I'm finding an equivalent fraction, whatever I do to the bottom, I must do to the top. I'm going to put some brackets on there just to help see what I'm doing. And I will begin. In this case, the top is potentially something that might have a cancelable term. So I'm going to leave it in factored form for now, just so I can compare it with my new denominator. My new denominator is going to be 2x times, or root 2x times root 2x. That's going to be 2x. Root 2x times plus 3, so that's going to be plus 3 root 2x. And then I've got negative 3 times root 2x. So I'm going to have negative 3 root 2x. And then finally negative 3 times positive 3, which is negative 9. Same as what happened before, these two center terms are going to cancel out. So I'm going to rewrite my new denominator now as 2x minus 9. I'm going to look at my current numerator and see if anything cancels, because maybe I would have that as my numerator, but I don't. So I might as well go ahead and multiply this through. Okay, so 2x, root 2x times the root of x minus 2. I just want to remind you, if I have a squared and b squared, that is the same as ab all squared. Okay, so that's an exponent law. And these have the same power. Their power is the root square root, or the power of 1/2. So that means I can actually put them together. So I'm going to do the root of x times 2x, which is 2x squared, subtract negative 2 times 2x, which is 4x. Okay, so I can put those together. And then plus 3 root x minus 2. Okay, and I expanded it out, but still nothing can be canceled or simplified. So then this is my final answer. The homework for this lesson is page 4, questions 1 and 2.